Natural gas feeds the engines of 1,000,000 machines, and flowing oil smooths the movement of the working parts. With gas and oil, the motors hum, and the wheels roll swiftly and easily. From the foothills of Alberta come the largest supplies of oil yet discovered in Canada. Churner Valley is a long, wrinkled dent in the landscape southwest of Calgary, set under guard of the Rocky Mountains. A fistful of tiny towns are flung out along its 20-mile length. It is range country for the herds of half-wild horses, but rising in the background are the towers of a newer power that is stronger and swifter than they. The towns get their names from the company oil wells, on which they depend for a living. Small towns, catching short roots in the green-brown earth. They will live so long as the oil well pays, and no more. In Churner Valley, the field has lasted a score of years, and a few solid towns have grown and stayed. But no one knows how long the wells will flow, so farther afield across the prairie, the search for new wells goes on. Oil men, like the cattlemen, their neighbors, are gamblers. They know a freak chance of nature may throw their luck in or out, may mean that they stay or go. No one knows for sure when a well is sunk, whether it will strike oil or not. And at the end of a job, the workman and his work must be ready to move on, leaving the finished well to work for them, small and undramatic in the rolling stretch of foothills. But there is less guesswork now than there used to be when a new well is begun, for geologists have learned to read the signs of the rock show where oil is to be found. At new wells being drilled, core samples of rock from each layer tell the structure of the earth below the surface. Fossils in the cores tell the history of oil. Fossils are remains of the tiny creatures whose bodies made the oil long ago in forgotten shallow seas. Stone and limestone are porous kinds of rock in which oil is held. In Churner Valley, it is a bundle limestone layer in which the oil traps lie. Whenever a new area is to be explored, go out. A seismograph is an instrument that records the waves of an earthquake. One truck erects a portable derrick. And digs a miniature well. The men fill dynamite into the hole to make a minor earthquake down through the layers of rock. When the blast goes off, each layer of rock shakes with a different wave or vibration. The seismograph truck records these vibrations. From them, geologists can tell what kinds of rock there are, how they lie beneath the surface, and which are likely to hold oil. All the information is collected, and samples are analyzed and classified. At last, a complete map of the geology of the field is known. Gas can travel underground from place to place, through through the pores in the rock. It drives with it oil and salt water left over from the ancient shallow seas. But where earth is crinkled into dome-shaped folds, the oil is trapped under layers of shale or limestone. When a well is sunk, it may turn out to be just a dry hole, or a water well, or a well producing gas and oil. A new well is begun on the foothill plains. First, a cellar is dug. A foundation is laid to hold complicated drilling machinery. Then a derrick is erected. Steel girders reach 140 feet high for a tower to work the head block of the drilling gear that will slide repeatedly down from the top as the hole goes deeper. A tower to lift the miles of drilling pipe that will be lowered length by length into the well. Along the ground, pipes are laid ready for use when the well is finished. They will lead the oil to separate storage tanks and take off the waste gases a safe distance from the well. Cement is mixed for concrete pillars to support the derrick, for the mighty machinery of the drill will work heavily and hard, 3 shifts, day and night, for half a year perhaps, until oil is reached. The crew stacked pipe lengths against the side of the derrick, ready to put down the well as the hole deepens. The drawworks is the machine that drives the turning parts. The head block shaft of the rotary drill. The turning rotary table on the drill well floor. The diamond drill bit revolving underground. Depth and pressure are checked under the watchful eye and keen hand of the driller. Vibrations of the brake tell him the hardness of the rock below. Mud lubricates the turning parts, and when the pipes are pulled to change the bit, mud plaster keeps the well from caving in. Some modern derricks are portable ones that can be put up quickly and taken down for use again. They work, however, in much the same way as older kinds of wells. Sliding down gradually from the top of the derrick, a long rod turning round and round revolves the drill bit that bites through the rocks below. It goes down 50 to 200 feet a day. Sometimes the bit is lost, and drillers have for it a mile perhaps below the surface. Frequently the drilling stops, for the drill bit has worn out and must be changed. All the length of pipe that has been sunk is pulled up and stacked, 90 feet of it at once, against the side of the derrick. The men clamp huge wrenches to unscrew the sections of the pipe. They stack it against the derrick again. On a platform halfway up, the derrick man guides the top of the pipe over to the side and swings the big hook down to the crew below. When all the pipe is pulled up, the worn drill bit can be replaced. Then men fasten the new bit. And send the lengths of pipe down the hole again. Screwed tightly together by means of clamps and winch. Then drilling starts again. New lengths of pipe are added as the well deepens, till once again the drill bit wears out and must be changed. The crew who pull the pipes are roughnecks, a name that tells the toughness of their work. As the well nears completion, the deeper pipes bring up a muddy mixture from underground, and changing the drill bit is harder, longer work. These days, not many wells are gushers that spout high in the air, for when oil is reached, a system of valves is ready to control the flow. When the well strikes oil, the roughnecks pull the pipe lengths up, unstack them from the derrick, and roll them outside, ready for use again in another well. Then they put a casing down the well to hold the wall. In Churner Valley, wells need acidizing to break down the pores of the limestone, allowing the oil to flow. Acid is brought in trucks and piped to the well. Flare pipes carry off the wicks a safe distance from the well, where they can be burned. The burning flares of the wells across the valley are plumes of smoke by day and jets of fire at night, when the workmen go home from their 8-hour shift. A well, when the derrick is down, is a small compact set of valves and pipes. A flowing well works by itself, but some wells need a pumping jack to get up the oil. The pumping jack is a kind of robot men have made to work for them day in, day out, so long as the well lasts. Oil is measured in barrels. Thousands of barrels of the crude oil stock are sometimes stored in field tanks. From there, the oil men load it into trucks and take it off to pipes or into some fields to cleaning plants. The receiving pit may be just a large hole dug in the ground. The pit stores the oil until it is pumped out again to be cleaned or to be sent to the railroads as fuel. Pipes are laid to serve each individual well. But larger pipes, leading to the processing plants and refineries, serve many wells and companies together. Each company has a quota of the number of barrels it is allowed to send by pipeline every day. At scrubbing and absorption plants, gas is separated from the oil, and the high-octane gas for aeroplanes is taken out. At refineries, oil is purified and separated into its commercial products. In the cracking plant, crude oil heated into vapor cools in high distilling towers. The vapor that rises to the top of the tower liquefies as gasoline. From the next highest level comes kerosene, then diesel oil and fuel. From other types of oil, the residue produces tar and asphalt, or lubricating oil and wax. Oil from 1,000,000 years underground goes out to serve Canadians. It is power for our trucks and farm machines and many other kinds of locomotion. It smooths our activities in many ways at home. In lubricating grease and oil, in wax for floors and cleaning fluids, in heating fluids for our stoves, in paraffin for sealing jars, oil and gas and all the byproducts of petroleum are an important part of our modern way of living.